All right, example 5 says to differentiate y equals sine of cosine of tangent of theta. One thing I will say, people typically make a mistake with this one and think it's a product rule. It is not a product rule. If it was a product rule, I would have to have sine of theta times cosine of theta, something like that. Okay. If I have two trig functions being multiplied, they would both have a variable on the inside of that function. So this one is actually a chain rule. It is sine of cosine of tangent of theta. So if you were to find a value for this, you'd plug in theta to tangent, then you'd find that number, plug it into cosine, then you'd find that value and plug it into sine. Okay, so it is a chain rule. And once again, it's going to be a double chain. Okay, so this one is another double chain rule. So first things first, the inside is all of this. And that makes sine our outside. Okay, so that's our first inside and our outside. So y prime is equal to the derivative of sine is cosine with all of the original inside. So cosine of tangent of theta. Okay, now the way that chain rule works is the derivative of your outside with your original inside plugged back in, okay, times the derivative of my inside. So here's my inside. So now for this case, I need to figure out, well, who is the inside of this piece? Tangent. So this is my in, and then this is my out. Okay, so we're going to multiply it by the derivative of the inside, which is another chain rule. So derivative of cosine is negative sine with our original inside, so tangent of theta, times the derivative of the inside. Derivative of tangent is secant squared of theta. And then I would just do just a very small rewriting. We usually put negatives in the front so it doesn't look like subtraction. So y prime equals negative cosine of tangent of theta times sine of tangent of theta. So this is times tangent of theta times secant squared of theta. And that would be my answer for example 5.